Hello guys, this is Group Lifesavers and today's topic is Titanic, machine learning from disaster. We divided this presentation into 4 parts, namely target understanding, data preparation, modeling and evaluation, and finally extra solution. First thing to do is to understand the target of this program. The most basic thing is using the provided test set to train the model and then use the model gain to predict the survival probability. In this way, we can complete the analysis of what sorts of people were likely to survive. The outcome of the whole process should be a list of 0 or 1 values, which represents survival or not. The next thing to do is to understand the current data we have, especially the training set. Here is the example of the training set. It has 12 different attributes in total, including 7 numeric attributes and 5 nominal attributes. The class value here is the column named survive. The value 1 indicates survival and the value 0 indicates no survival. Before the modeling process, we need to carry out the data preprocessing on the training set. So what did we do to the training set? There are mainly 2 things. First, we did some changes on the survived column. We converted this numeric attribute into a nominal attribute. After doing this, we can apply more classifiers on the training set. We will change it back after the results come out. Secondly, we filled in the missing places in the table with the blank values as a way of data cleaning. The next thing is modeling and evaluation. There are 44 different kinds of classifiers in Weka, which can be used to set test file. To start with, we use cross-validation and percentage split, respectively, to select the top 5 classifiers which have the highest accuracy above 80%, namely SGD, SMO, multi-class classifier updatable, JRIP, and LMT. Here's the table which illustrates the accuracy of these 5 classifiers. After choosing the suitable classifiers, we set the test file into the train file and get 5 different answers in output. Subsequently, we transfer output predictions into CSV and submit the results on Kaggle. Taking what we have into account, JRIP has reached the highest score. Now let's move on to what combination of features we should choose. We use control variable method. First, we delete 1 feature and keep the others the same, and apply 5 classifiers. And then, we record the accuracy of each combination with cross-validation and percentage split. Finally, we compare the results with the original accuracy. We observe that for most features, the accuracies just fluctuate slightly. However, when we delete 6, the accuracies of all classifiers decline from around 80% to around 70%. It implies that gender is a very important feature for these 5 classifiers to predict whether people survive. As for the other features, they may influence the prediction in a complicated way. Besides, we employed another method to solve this problem, predicting with neural network. We use the well-known machine learning framework, PyTorch, to do this. Our target is to train a 2-class classifier, so let's focus on the model. As there are 7 attributes that are either numeric or can be easily encoded to numbers, we intuitively constructed it with 3 linear layers, which maps the 7 attributes, that is 7 dimensions to 64, then 128, and finally 2 dimensions, yes or no. On the right, there is a graph indicating the relation of layers. This table shows which we were choosing for training. The columns in blue are attributes we selected. We use ReLU as the activation function. The loss function is cross entropy, and Adam as optimizer. This table is about the attempts we made. The block in green is the best score we got, which is in the 4,200 41 placed out of more than 10,000 teams. What's more, as in these model names of the passengers are not taken into consideration, so we also tried it to use LSTM for text-related train. But it turns out that it shows no improved accuracy, just 75%, which is lower than 78% of the linear model. Maybe more time is needed to adjust the hyperparameters. So that is the end of our presentation. Thank you.